Hi, I'm Tanim, and in this video, we will make an object detector Android app using TensorFlow Lite. So it will take some time, so let's quickly get into it. So this is the whole repo, and here we have everything we need from Android app to the training scripts. So to make the whole app, first of all, we have to train the model, and we will use TensorFlow Lite Model Maker to do that. And I followed the official documentation provided by TensorFlow to train the whole model. So here we have almost 9 steps. So you should go through every steps to understand what's going on. But there's a thing, this tutorial is kinda outdated, like it was last updated in 2021. And you may run into some problems while running the training script right now. So that's why I'm here. So I'll try to solve every possible problem you'll face and ultimately make a fully working Android app. So let's get into it. Let's start with making our dataset. So I'll use this dataset, football player detection image dataset from RoboFlow, and again the link will be in the description. And if you wanna make your own dataset, you can simply check out one of my previous videos on YOLO V8 where I showed you how to create a dataset using RoboFlow. So you have to click download dataset and make sure to select the Pascal walk format. It will generate an XML annotation file. So we need this format and then download zip to computer. So after downloading and splitting our dataset, we have to upload it in our Google Drive. So okay, this is the zip folder. So let's extract this. So if you notice, it generated 3 folders: test, train, and valid. So in test we have the images and the annotations, and the annotation are in XML file. So this is really important. So make sure you have the annotation in the XML format. And in train is the same, and the same is in the valid. So but there's a thing, to train our model we have to separate our images and the annotation folders, just like this. Let me show you. Okay, just like this. As you can see here, we have the images, test images in one folder, and the annotation of these images are in a different folder. But in our dataset we don't have these separated, so it will take a while. It's kind of hectic job to do it manually, like separate the images and the annotations. So that's why I made a Python script to do it automatically. So let's check this split. You can find the script in GitHub. So here we have, so this is the whole script, and you just have to provide the provide the paths to your train, test, and valid folder, just like this. You have to provide the paths of this train, test, and valid, and the script will automatically generate 6 folders, and it will split the images in the train image and annotation in the train anno. Same for the test image and test annotation, just like this. And make sure to create a folder like this data split where you have these folders annotation, so it will be easier for you to upload in the Google Drive. So after doing this, go to your drive, then click new, folder upload, and then upload the data split folder. This is my folder where we have the images and the annotations. So these are the images and these are the annotations. So we are good to go now. Let's move on to Google Colab and train the model. Okay, so we're in Colab, and the first thing you have to do is you have to change the runtime and enable the GPU. This is really important. If you run the script in a CPU, it will take forever. So make sure to select T4 GPU. And as I mentioned earlier, if you run the official documentation and run the official script, you may run into some problems. And the first problem is TensorFlow Lite Model Maker, the package we are using, it does not install in a Python 3.10 environment. And right now the version of Python in Colab is Python 3.10. And I guess TensorFlow team is trying to solve the problem. But till now, what you have to do is, you have to create a virtual environment of Python 3.10 and then install the package. So these shells, these 5 or 6 shells are simply to install, like create the virtual environment. So just simply run those, run anyway. Okay, for some reason this shell was missing. So just simply run everything. And you have to sometimes give permission to proceed. Just click Y and enter. And here also click on the text and click Y. Again. And this shell is installing the TF Lite Model Maker. It will take some time. Okay, so after running all these, we have finally created a Python 3.9 virtual environment in Google Colab. So there are some additional packages we will need. So simply run everything. Okay, so everything is done. Let's start our training. And the problem with virtual environment is we can't use a different shell to train our whole model. It's funny because we use Jupyter Notebook or Colab to get access to the shells, but in a virtual environment you can't use the shells. So it is what it is, guys. So we have to run the whole training script in one shell. So to make it look good, I have created a train.py, and in train.py I have the whole training script. So let's check it out. Okay, so you can find the training script in our repo, and then we have to upload the training script in Colab with this upload button. So as you can see, I have the training script, and after doing that, just run this and hopefully it will start our training. And we're pretty much done. So now I will try to explain how the training script works. On the first part, we are importing the necessary packages, and we're providing the labels in the label map variable. So make sure to do that. And we have 4 classes in this dataset. If I take you to the dataset, they mentioned that the dataset has 4 classes: ball, goalkeeper, player, and referee. And here you have to mention the paths of the image and annotation directory. And as we separated the images and the annotation, so there should be 6 variables. Okay, so how can you get these paths? So simply go to your Colab and go to your drive and select the folder where you uploaded the dataset. For me it was in data split. So these are the folders, as you can see. So you just have to copy the paths. For example, if I want to copy the train image directory, simply click here and click copy path, and then provide the path. For the train image, it's this. So I guess you get it. And after that, we have to mention the train image, annotation, and the label map in one variable. As I mentioned earlier, we use the Pascal walk method to annotate our model. So Pascal, we have to mention the train image, train annotation, and the label map. Same for the validation and the test. And we are using a pre-trained model to train our model. And this is the model. And there are a lot of models which you can use. And to know more about it, please check out the official documentation. I'll provide the link in the description. So after all that, this command trains our model. So in train data, we're passing the train data, and in model spec, we're passing this model, and epoch should be 50, batch size is 10. We can play with the epochs and the batch size and train the whole model through. And after training the model, we're evaluating the model with the test data. And over here, we are mentioning the name of our trained model, and you can edit this. Like as we are training a football dataset, we can rename this into a footballdata.tflite or anything. That's not an issue. And it will also generate a labels.txt file, and this command will download the train model from Colab. So the code is really simple, and if you run into any problem while running the script, please comment down below. I'll try to solve your problem. Okay, so let's go to our Colab and then let's run the script.
One eternity later.
Okay, so after about 3 hours, finally we got our train model. So after the training part, you should get a model named train model tflite. So you can run this script to test your model. So to do that, you have to provide the path of your model right here and the sample image path here. We have the sample image, this, and this is our train model. So let's run this. Okay, so this is the result. As you can see, it can detect players pretty well, and the accuracy is really good. So this is it for today. In next video, we will make an object detector Android app using this model. So till then, bye bye.